Boyles law. What is Boyles law saying? Boyles law states that the volume of a given mass of gas, is inversely proportional to the what? Pressure, provided the temperature remains constant. Please don't forget this. Provided the temperature remains constant. Now with this, we are now going to see how to change our proportionality sign by introducing a constant. And that will be volume is equal to our constant is introduced, and then all over P. Can you see? We have just changed the proportionality sign by introducing our constant K. Now we want to make K our subject of formula, and then we are going to cross multiply. So K times 1 is K. And volume times pressure is equal to what? Volume times pressure. Don't forget, your P represents pressure. Now with this, it means wherever I see K in Boyles law, it means volume times pressure. I repeat, in Boyles law, whenever you see K, it represents volumes times pressure. Now let's do that now. So we are going to have our volume, our K, which is V1, which is now going to be V, and P. Now this K represents V, so we are going to represent it by writing V1 P1 equals to what? V2 and P2. So this formula is what we use to represent Boyles law. I hope I made myself clear. So Boyles law states that the volume of a fixed mass of gas is inversely proportional to the pressure, provided the temperature remains constant. Now we came here and we changed our proportionality sign by introducing our K, and then we cross multiplied, and then we came with this formula where K is equal to volume times pressure. Now with this, when we have our K is equal to volume times pressure, we have substituted for K, which is V1 P1 is equal to V2 and P2. Now let us move and explain little thing about what Boyles law is saying. Now let's use a practical illustration to explain what Boyles law is saying. Remember, Boyles law states that the volume is inversely proportional to the word pressure. What this thing is saying is that when there is an increase in volume, then the pressure will be decreased. When there is an increase in volume, there will be a decrease in the pressure. Now with this, let's use this as an example. This is a plastic container. Let's take for instance, it contains about 30 cm3 of the gas. Or let's say the volume of this container is 30 cm3. Now with this, the volume is 30 cm3. 30 cm3. What would you observe? When we have some air particles or pressure from air hitting the external walls of the container, we can imagine that the pressure at this moment, let's say the pressure is 200 millimeter mercury. So this is the container that has a volume of 30 cm3, and there are pressure, external pressure acting on the external walls of this container. And despite this pressure, the volume of this container is 30 cm3. Now what will happen if we increase the pressure? Now we want to increase the pressure. Now let's say we have increased the pressure to about 200 millimeter mercury. What do you think will happen to this container? Obviously, the container will shrink. The container will shrink. So this was the volume when the pressure was 200 millimeter mercury. Now this is the volume 2 when the pressure is equal to 400 millimeter mercury. Now, what did you observe? When we have a pressure of 200 millimeter mercury, the volume was 30 cm cube. I repeat, when we have a pressure of 200 millimeter mercury, the volume was 30 cm cube. Now we have increased the pressure to about extra 200 on it, making it 400 millimeter mercury. What do you think will happen to the container? The container will decrease. Now we are going to calculate what will be the new volume of this container. Follow me to the next video. Now, if you look at the board from our previous diagram, this is the volume of our container, which is 30 cm cube when the pressure on it is 200 millimeter mercury. Now, if we increase the pressure on this container, let's say we are increasing the pressure now on this container, what do you think will happen to this container? It will decrease. So let's say we have decreased the container by applying more pressure on it. So you can see the pressure has increased. The initial pressure before was 200 millimeter mercury, and now the new pressure is about 400 millimeter mercury. With this, what will be the new volume? That is what Boyles' law is saying. Remember, here the pressure was low. Look at the volume we had. But now look at the pressure has increased. What volume do you think we are going to have? Now we now go back to our formula of Boyles' law, which explains that P1 V1 equals to P2 and V2. I hope you recall this formula. Now, what is my P1? It means the pressure 1, the first pressure acting on the container, and that pressure was given as 200 millimeter mercury. What volume was attained when the pressure was 200? The volume is 30 cm cube. Now, what was the new pressure? We have increased the pressure to about 400 millimeter mercury. Now, what will be the volume? Can you see? So the volume is unknown. So we are going to make volume subject to formula. So we are going to write 200 times 30 is equals to 6,000 equal to 400 V squared. Now, what do we do in this case? Divide by 400, divided by 400, and then my V2 is cancels this, and then we are left with V2. Then 6,000 divided by 400 is equal to 15 cm cube. Now, with this answer, do you think the answer is correct? I think the answer is correct. Why? Because the pressure before was 200 millimeter mercury and it has a volume of 30 cm cube. But now we have increased the pressure to about 400 millimeter mercury. What will be the new volume? The new volume will be 15 cm cube. When the pressure and volume are the two major parameters we are dealing with in Boyles' law, whenever the pressure decreases, the volume will increase. That is what this thing is saying. Also, for Boyles' law, whenever the pressure increases, the volume will decrease. So let's not forget, Boyles' law states that the volume of a fixed mass of gas is inversely proportional to the pressure, provided the temperature remains constant. Of a fixed gas, was 30 cm cube at a pressure of 400 millimeter mercury. What will be the new pressure if the volume increases two times the initial volume? Now, I want you guys to do this and submit on this comment section. Please drop your comments and make sure you follow me by giving me a thumbs up. Thank you.